Okay, so this is our final video in the probability and counting methods unit, and certainly the final exercise on counting methods, where we just want to look at putting together our knowledge of arrangements and selections to then actually calculate probabilities. So this is really just a simple extra step at the end. So let's just work through some examples here. So no new formulas or techniques. Example 1, if the letters of the word diary are arranged in a row at random, what is the probability that the vowels are at either end? So this is pretty much the same question as asking how many different arrangements are there with the vowels at either end. If we want the probability, we then just need to be able to arrange to take the number of arrangements that have vowels at either end divided by the total number of arrangements. Okay, so let's first of all calculate the total number of arrangements because we're going to need that as the denominator of our probabilities. Total number of arrangements is going to be, we have 5 letters and we can arrange them in any order, would be 5 factorial. Okay. 5 factorial, which is menu 5(1). Oh, sorry, we want 5 factorial, 120. Okay, so then let's think about how many arrangements have the vowels at either end. Okay, so let's think about our 5 positions. As soon as you've got arrangements with restrictions, I really think it's easiest to sort of think about this sort of pigeonholing technique. Okay, we want the vowels at either end, which means there are 2 possible vowels that could go at the start, and then if we've placed one of the vowels at the start, there's now only 1 remaining vowel that can go at the end. Right, then we have 3 other letters that aren't used, so there are 3 options for this position, 2 options for this position, and 1 option for this position. Okay, so that is 2 times 3 is 6, times 2 is 12, so that's 12 different arrangements. So 12 arrangements with vowels at the ends, okay? And so therefore the probability that the vowels are at the ends is going to be, there are 12 possible arrangements with the vowels at the ends out of 120 possible arrangements in total, and so then 12 on 120 is just going to be 1 on 10, or 0.1. Okay, part B, the probability that the vowels and the consonants occupy alternate positions. Okay, so again, we're going to have our 5 positions. Now, in this particular example, it's not an option for the arrangement to start with a vowel because we only have 2 vowels. So if they're to alternate, we must have consonant, and there's 3 consonants, followed by vowel, and there's 2 vowels from which to choose from. So we're going to have consonant, vowel, consonant, vowel, consonant. Okay, so just thinking about the consonants, boxes, there are 3 consonants that could go in the first position, 2 left to go in the middle position, and 1 left for the final position. Thinking about the vowels, 2 vowels can go here, 1 vowel can go here. So again, we have 3 times 2 times 2 times 1 times 1, which is also 12. And so the probability that they alternating vowels and consonants, is going to be, again, 12 out of 120, so 1 in 10. Okay, part C, the probability that the vowels are all together. Okay, so this is best to think about the vowels as being just one object because they need to be grouped, and then we've got our 3 consonants. So actually we essentially have 4 different things to be arranged. There's 4 factorial ways for those things to be arranged, okay? And within the vowels, there are 2 ways for those to be arranged, or 2 factorial. So if you had 3 vowels, you could say there's 3 factorial ways that those can be arranged. So essentially, this is 2 factorial times 3 factorial, okay? Yeah, the risk that you run with this is 3 times 2 times 1. The problem is then it's not just 2 factorial times 3 times 2 times 1, because you haven't actually then thought about all the different ways that the consonants might be arranged with the vowels. Okay, so you actually haven't thought about, you would then need to think about, okay, but there are, 4 different ways that I can combine together the vowels and consonants. So that's why I always think it's easiest to actually lump the vowels together as one object. There are 4 factorial ways to arrange those objects, but then we then also need to multiply, sorry, it's not 3 factorial, it's 4 factorial. We then also need to multiply by 2 because there are 2 different ways to arrange the vowels. If there were 3 vowels, it would be multiplying by 3 factorial, not just times 3. So that's why I'm writing 2 factorial there, even though 2 factorial is just 2. Okay, so we have 2 factorial times 4 factorial. Sorry, so you need to type the number first when you're doing factorial. So 2 menu 5(1) times 4 menu 5(1). So there are 48 different arrangements with the vowels together, and so the probability of having the vowels together is going to be 48 out of 120. 12 goes into both of those, that's 4 and 10, so 2/5. The probability that the letters are arranged in alphabetical order. So there's only one way to arrange the letters in alphabetical order. So therefore there's only 1 out of 120 possible arrangements that would have the letters in alphabetical order. Okay, example 2. James randomly selects 4 marbles from a jar that contains 6 blue marbles and 10 green marbles. What is the probability that James selects no green marbles, at least 1 green marble, 3 green marbles, given that he selects at least 1 green marble? Okay, so this is a selection. The order doesn't matter, so it's an NCR rather than an NPR. So we first of all need to know the total number of possible selections, okay, because that's going to be the denominator. Total number of selections. He has a total of 26 marbles from which he wants to choose 4. 26, choose 4. We can work that out, but we can just write it as 26, choose 4 in our calculations rather than actually using the number 14950. Okay, so the probability of getting no green marbles means that he selects all blue marbles. Okay, so it means that from the 6 blue marbles, he's going to choose all 4 from the 6 blue marbles, and from the 10 green marbles, he chooses none. Now that's just 1, so we actually don't need that bit, over the total number of selections, which is 26, choose 4. Okay, so menu 5, 3, 6, choose 4, and so then we need 6, choose 4 divided by 26, choose 4, which is 3 on 2990. Okay, the probability of choosing at least 1 green marble, okay, means he could choose 1 green or 2 green or 3 green or 4 green, but actually that's just going to be the probability of at least 1 green is actually just 1 minus the probability of no greens. So 1 minus 3 on 2990, 1 minus, probably do that in your head just as easily, 2987 over 2990. And then part C, the probability that he selects 3 green marbles given that he selects at least 1 green. Okay, so probability of 3 green given at least 1 green. Okay, so we need the intersection of these two things, conditional probability. The number of ways of choosing 3 green and at least 1 green, that's just 3 green, over at least 1 green, which we've worked out in the previous question. Okay, probability of at least 1 green. Okay, so probability of choosing 3 green marbles. Now, it's really important. Sometimes people go, okay, well, choosing 3 green marbles is just, sorry, so how many greens do we have? 10 green. Okay, it's just going to be 10 choose 3 out of 26 choose 4. But the problem is, if you're choosing 3 greens, you have to choose 3 greens because you still need to choose 4 marbles. You have to choose 3 greens and 1, whatever the other colour was, sorry, 1 blue. Okay, so the number of ways of selecting 3 green marbles is not just 10 choose 3, because you are still choosing 4 marbles. So you need to do 10 choose 3 times 6 choose 1 over our total number, and then that's dividing by our probability that we've already got from the previous question, 2987 over 2990. Okay, so let me work out this one. Control divide, menu 5, 3, 10 choose 3 times menu 5, 3, 6 choose 1 over menu 5, 3, 26 choose 4. Okay, so that is 72 over 1495 multiplied by 2990 over 2987. Given that I've already got that number here, I'm just going to do answer divided by this one up here. Okay, so we get 144 over 2987. Only give them as decimals. They'll be ugly, big decimals. Only give them as decimals if, because you'll need to round them off if the question specifies to give your answer to 2, 3, 4 decimal places, whatever it might be. Okay. All right, so the work here to finish off the probability topic is exercise 10D, all the questions there.